Good morning and welcome everyone. I hope you all had a great weekend and welcome to the beginning of the rest of the year. My name, if we have not had the pleasure to meet, is Mr. Colodi. It's nice to meet you all, and I'd like to let you know that either myself, Mr. Colodi, or Ms. Shoemaker or Ms. DeMarco are going to be handling the lessons, homework, classes for the rest of the year. We've got you. You're in good hands. First, I'd like to introduce my associate right here, Griffin. All right, he might be on videos here. He just wanted to say hello really fast. But I'm going to be sending some notes and literature. We're going to keep things roughly the same. There are a few things that I do slightly different than Mrs. Middleton. And by the way, she will still be on Google Classroom. Even though she's not physically in the school, she will see your posts and things you could wish her well through Google Classroom or through email. She has not gone into some parallel universe, so you can always find her. All right, so with that said, let's begin Unit 14. Dun, dun, dun. All right, I'm going to pop out of here so you don't have to look at this mug for the rest of the lesson. All right, so actually, let me pop in just one more time. Unit 14, what is this about? So until now, right triangles have been our life. All right, everything we've done, either with Pythagorean's theorem or the trig that you've done so far, has dealt with right triangles. You know what? What about all the triangles that are not right triangles? They've been left out until now. All right, if you see a non-right triangle walking down the street, you could be like, hey, forget about it. I got you now. All right, because this whole unit deals with triangles that are not right triangles and some of the laws that we can use to solve non-right triangles. Beginning with the law of sines. All right, so what is the law of sines? It deals with an oblique triangle. And as I just said, oblique triangles are any triangles that are not right triangles. In general, if you have one side and you have any other two measures, you can solve the triangle. We are going to be learning over the next few days the law of sines and the law of cosines. Today, we'll focus just on the law of sines. So I left a little space open right here. What if I give us a triangle and let's see here. Let me just, I'm making this completely up right now. All right, so let's say that this angle right here, I don't know, is 30 degrees. And this angle right here is 45 degrees. And let's just say that this side over here is 2. I'm just giving some basic angles. All right, we can solve this triangle. And by the way, it's a non-right triangle. How do I know that? Well, let's see. 30 plus 45 is 75. And I know a triangle adds up to 180. So 180 minus 75 gives me a third angle of 105. Now, let's label this triangle. Recall that angles of a triangle are always used with capital letters. So let's call this A, B, and C. I'm making this up right here. So I guess then 2 would be side lowercase. Remember, sides are lowercase, angles are uppercase. So this would be side B over here, and this would be side C right here, lowercase c. What does the law of sines state? It's very basic, actually. The law of sines basically should be called the law of proportions. Done. Lesson over. The law of proportions. In other words, the proportion of the side divided by the sine of the opposite angle to that side is equal to the proportion of side to the sine of the angle of any other part of the triangle. So let's just say I want to find side C. Well, I could say side C divided by the sine of 105, the angle that's opposite that. I could create an equation right there. Suppose I wanted to find side B. Let me use a different color pen there. I could use the same exact existing ratio. As long as I have no variables for one fraction, I could use it to find any other variable, so side B, over the sine of the opposite angle, which is 45 degrees. I'm not going to solve them right now. I just wanted to show you the setup to show you how the law of sines works, or the law of proportions. Wow. All right, so the law of sines in general says that side A divided by the sine of angle A equals side B over the sine of angle B equals side C over the sine of angle C. All righty, let's get to 3 examples. We're going to solve triangle ABC given this following information. All right, so we know that angle A is 34 degrees. We know that angle B is 120 degrees, and we know that angle, or side C, I'm sorry, is 200. 200 what, Mr. Cody? Well, doesn't matter. Feet, inches, meters. So let's draw ourselves a triangle right here. I'm just going to draw it up here in this open space. And let's say that this is angle A right here. And let's say that this is angle B up here. I'm just trying to make this, I'm looking at the angles, trying to make it as realistic as possible. This is 34 degrees. This is 120 degrees. And then we have angle C over there. And then we know that side C is 200. Always label. Now, one thing I like to be is ultra organized. All right, one thing I like to be is ultra organized. So let's list what we don't know. We don't know side A. We don't know side B. And we don't know angle C. Why don't we begin with angle C? That might be the quickest one of all. So angle C can be found just by taking 180 minus the sum of 120 plus 34. And if you hear some music in the background, that's just my daughter Sheridan playing some nighttime music, even though this is the morning. Yes. And so we end up with 26 degrees. All right, someone would like to say hi very quick, and then she is going to go upstairs. So say hi.
Hi. Say bye.
You're gonna go upstairs. Yeah. Bye. I'll beat you upstairs. Go. Next, let's find side A and side B. But now that we know that this is 26 degrees, we can use this information. I now have an angle and a side opposite that angle. So we need to find side B. So to find side B, I'm going to use side C divided by the sine of angle C, which is 26 degrees. And I'm going to set that equal to B divided by the sine of angle B, which is 120. Okay, so through some cross multiplication and division, we're going to find that B equals 200 times the sine of 120, 120, divided by the sine of 26. And what does that give us? That gives us, oh, by the way, this is my calculator ready form. All right, if Mrs. Middleton has said calculator ready form before, CRF, calculator ready form, you get 255. There is side B. All right, so now we just have to do side C. I'm sorry, side A. All right. So let's see here. Let's find side A. So I'm going to find side A. We're going to take the same ratio, 200 divided by the sine of 26. And we're going to do A over the sine of 34. So let's see, let's find side A here. That's going to be 200 times the sine of 34 divided by the sine of 26. Okay. And I realized I made a flub. I'm going to use the erase symbol. See, first day, first flub. I used my wrong calculation here. B is actually equal to 395. Oops, I'm still using the erase symbol. It's equal to 395. My apologies. I hope you could forgive me on this first day. And when I do find side A, this equals 255. Oopsies. But by setting up those ratios, equal proportions right there, I found my answers and I solved the triangle. Yay. Let's get to example 2. Pause and rewind this video, slow it down, go at your tempo. Example 2. We are now going to solve another triangle, a non-right triangle. This time the angles are in degrees and minutes. Not a big deal. Let's get after it. Here we go. Let me draw another triangle right here. So I'll call this angle A. I'll call this angle B up here, and I'll call this angle C over here. It says that side A is 19.7, so I'll do A equals 19.7. It says that angle B is 38 degrees and 40 minutes, so I'll put that right here, 38 degrees and 40 minutes. And last but not least, it says that angle C is 91 degrees, 40 minutes, so I'll put that right here, and 91 degrees and 40 minutes. Now what we need to do is find angle A. Why don't we do that first? Find angle A. So we could just add up the 38 degrees, 40 minutes. Let's do that. 38 degrees, 40 minutes. And let's add up the 91 degrees and 40 minutes. So if we do that, we get 129 degrees and 80 minutes. But we can't have 80 minutes. So let's add one more minute and get 100. I'm sorry, add one more degree and get 130 degrees. And there will be 20 minutes left over. So there's my angle A, 130 degrees and 20 minutes. Great. Now we need to find side B, and we need to find side C. So let's start with side B, shall we? We could use the ratio. Side A, which is 19.7, over the sine of angle A, which is 130 degrees and 20 minutes, equals, let's start with B. So side B over the sine of angle B, 38 degrees and 40 minutes. Through cross multiplication and division, we get B equals the sine, 19.7 times the sine of 38 degrees and 40 minutes divided by the sine of 130 degrees and 20 minutes. Sorry, I'm writing as neatly as I can. I know it's not that neat writing on the screen. And then side B for real this time, if I work this out, which like the good chef on a cooking show, I already did work it out, you get 16.1. Now let's find side C. Same ratio to begin. 19.7 divided by the sine of 100 degrees, 20 minutes, equals side C over the sine of 91 degrees and 40 minutes. So let's work that out. That's going to be 19.7 times the sine of 91/40 divided by the sine of 130 degrees and 20 minutes. And that's going to equal 25.8. For the sake of time, I've already calculated them for us. If you have any issues working them out on your calculator or how to do degrees and minutes on your calculator, I'm assuming that you did degrees and minutes with Mrs. Middleton. If you have not, message me or email me and I will answer your questions. Last but not least, example 3, a word problem, an application problem. Oh no, not a big deal. A ship is sailing due north. Captain notices a lighthouse 12.5 kilometers distant on a bearing of 38 degrees 50 minutes. Later on his trip, he notices the bearing of the lighthouse is now 135 degrees 50 minutes. How far did the ship sail between sightings? We're going to round our answer to the nearest tenth. So even though this is my first day with you guys, I believe this is what, a bearing 1 problem? Pardon me, everybody. So let's get to it. A ship is sailing north. And as he's sailing north, he notices, let's just say he's right there. He notices a lighthouse. There it is. There's the lighthouse. And it is, I'm going to continue this triangle right here. Here's north path. The lighthouse is 12.5 kilometers away. By the way, kudos to this captain. He knows exactly how far it is away. And on an exact bearing of 38 degrees and 50 minutes. Okay, that's a circle for degrees right there. Great. Then he continues to travel and he gets way up here, let's say. And now he notices that his bearing to the lighthouse, remember, this is bearing 1, so then this angle right here is 135 degrees and 50 minutes. Bearing 1 problems are always due to true north. Okay, it says find the distance that the boat has traveled, which is this distance right here. And here's our triangle. You could see it. 2 dotted lines here. You know what? Let me solidify these lines. There we go. Great. So the first thing we need to do is we need to find the other angles of this triangle. So I know that 135.50 and the angle right here add up to 180. So I'm going to do 180 minus 135.50. And just for the sake of time, I'm going to let you know that that's 44 degrees, 10 minutes. You could figure that out. So then if I add up 44 degrees in 10 minutes and 38 degrees in 50 minutes, just like I did up here, all right, just like I did up here, I will get an answer, and I'm just going to tell you what, 44 plus 38 is, what, 82? But 50 and 10 minutes add up to 60. So instead of 82 degrees, it's 83 degrees. 180 minus 83 leaves me with 97 degrees. I know I spoke that out instead of writing it. That's why you got to listen to the video. All right, so we got all the angles we need, but now I think we have what we need. I know that 12.5 divided by the sine of 44 degrees, 10 minutes, is going to be equal to my x over the sine of 97 degrees. And I work this out. I get x equals 12.5 times the sine of 97 degrees divided by the sine of 44 degrees in 10 minutes. And I get my answer of, to the nearest tenth, of 17.8 kilometers. And ladies and gentlemen, I present to you the law of sines. The homework is out of the book. Look at the unit syllabus that will be attached to this assignment, and good luck. Ask questions if you have them. Bye.